Welcome back to our plastic analysis class. And now we are going to continue with plastic analysis of frames. If you have watched the video that I have already recorded, I have mentioned there that when it comes to the frames, um, we have three different collapse mechanisms. One of these collapse mechanism is referred to as a beam mechanism. So it's not always the case that you have a load on beam. If the load is also applied to the column, it's still considered to be a beam mechanism. So you may have a force on the column like this, and in that case, you are going to have a deformed shape at the collapse similar to what you see on the screen. So these two is almost the same. So in the beam mechanism, basically, you're going to have three plastic hinges, similar to what we said for beam. And the location of these plastic hinges is always at the location of maximum bending moment, which is going to be both sides of your beam. And if you have a point load, under the point load that you have on your beam. And if it is column, again, it's going to be both sides of your column and also the location that the force has been applied to the column. So regardless it is on the beam or it is a column, this is considered to be a beam mechanism and it needs three plastic hinge for the collapse condition. And this plastic hinge is going to be always at the location that the bending moment is maximum. And one more thing that you need to know is that similar to the beam, let's say if you have a frame like this that has pin support and you have applied a force to the column and you want to look into your beam mechanism, since this one is already considered to be a zero bending moment, therefore you're going to need to have only two plastic hinges, one here and one here. Because this one is already considered to be a zero bending moment. So with three hinges, your structure can collapse. So you need to look into the support condition. If it was pin or roller, it can change your number of plastic hinge to 2 or 3. If it was fixed, you're going to have 3 plastic hinge. And if it was if it was fixed, you're going to have 3 plastic hinge. And if it was pin or roller, you're going to have 2 plastic hinge plus 1 hinge that you have in the support. So this is one of the case. Another one when it can occur, another collapse mechanism that can occur inside frame is a sway mechanism. So sway mechanism occurs when you have a lateral load on your frame. This lateral load basically can be at the joint, like this one. Okay, so in this case, your frame is going to sway laterally, and for this case, you need to have 4 plastic hinges in order to make your frame collapse. So these 4 plastic hinge again depends on the support condition. If your supports are already pinned, so that means by having 2 additional plastic hinge, your frame can collapse, similar to this case that I am drawing for you. So if you have a pin support, there is going to be a deflected shape like this, and 2 plastic hinge on top of your column is going to make your frame to collapse. So totally 4 hinges needed. These 4 hinge can be 4 plastic hinge or 2 plastic hinge and 2 pin or roller support. So this is what we call it sway mechanism. So sway mechanism either can be due to the point that have been applied to the joint of your frame, or sometimes the force is applied to the column, and due to the basically presence of the column, you are going to have column point load, you are going to have sway. So when the force is applied to the column, it can make not only a column mechanism or a beam mechanism, it can also make a sway mechanism. So you may have deflected shape like these, where you have 2 plastic hinges. So if the force was applied to column, you need to investigate 2 cases. One case is a column mechanism that is going to look like this shape. in which the collapse is going to occur in the column, and another one is going to be a sway mechanism in which the collapse is going to occur in the whole frame. And again, it depends on the support condition, as I said. If it is fixed support, you need to have 4 plastic hinge. If the supports, both of them are pin or roller, you need to have 2. And if one of them was pin, one of them was fixed, then you need to have 3 plastic hinges. So you need to be careful about the support condition. But in general, we need to have 4 hinges to make a structure collapse, have a sway collapse mechanism. Okay, and then the third condition is a combined mechanism in which the sway and beam or column mechanism are going to combine and generate a new type of collapse for us. For example, if you have a, let's say if you have a frame that has got lateral load and a point load on the beam like this, okay, the force can be similar or can be different. It doesn't matter how much is the value of this force. Then the first one is going to generate for you a beam mechanism like this one. The lateral force is going to generate a collapse mechanism like a sway type. And combination of these two can generate a combined mechanism. So in the combined mechanism, again, you need to have 4 hinges. And if your support are fixed, these 4 hinges are going to be 4 plastic hinge. If your support are pin, you may have 2 roller here, for example, or 2 pin support, then you need to have additional 2 plastic hinge to make the frame collapse. So it's very important for you to understand the location of this plastic hinge because it's going to change your calculation. When it is a beam or column mechanism, the location of the plastic hinge is always one the location of point load, and the other 2 at the end of your beam or column. In this way, is always at 4 corners of your frame. So both ends of beam and both ends of column, basically. And if you have a pin support, as I said, it's not going to be plastic hinge here, it's normal hinge. When it comes to the combined mechanism, again, if the support condition is fixed, 2 of your plastic hinge is going to be at the support. And the other 2, one of them is going to occur under the point load. The other 2 depends on the geometry of your frame. So either is going to be in the right side or in the left side of your frame, basically. So you need to look at the frame and find out the critical location for the plastic hinge. There are some rules, as I said. 2 of plastic hinge is always in the sway and combined is at the support. The other 2, one of them is going to be, if it is combined, at the location of load, and if it is sway, again at both ends of your beam. And if you have a combined column mechanism, this one is a combined beam mechanism because it's the combination of sway plus the beam. This is why you can see you may have a combined column mechanism. So in that case, again, you need to have 2 plastic hinge at the base, one at the location of column, and another one you need to see the geometry of your frame to find out where is the maximum bending moment and it's going to be placed there. If you're not sure about this, you need to just examine different cases to find out the right plastic hinge for that case. Okay, inside your notes, I have one example for you for the frame. That in this example, we have a frame that has 3 point loads applied to it. 1 point load in the beam, 1 point load in the left column, and 1 point load to the right column. So basically, we have all cases included in this example. So you need to study this one by yourself. I'm not going to go through it, but instead I'm going to show you another example that was given to students during past semesters. So this case is a complete case that has beam mechanism, column mechanism, sway mechanism, and combined mechanism. So you can see, for example, here, in order to investigate, one of the collapse mechanism for the column is when 1 plastic hinge is here and 1 is under the load. And since the support is pinned, so there is no plastic hinge, but we have only hinge. And then we can calculate the internal force equal to external force and calculate how much MP is this. So similar to the previous example that we solved for beam, when it comes to frame also, you need to investigate each scenario, each collapse scenario separately, and then at the end you come up with the largest MP or the smallest force and say that that one is a critical condition for your frame. So here, for example, in this case, since we have a different type of collapse mechanism, we need to calculate and examine them one by one. The first case is where the collapse occurs in the left column. So we have done the calculation. The second one is when the collapse occurs in the beam. It's similar to what we did for the beam. The third case is the collapse in the column, in the right column. And the fourth one is sway mechanism. And then we have after that combined mechanism number one, which is a combined beam mechanism. And then combined mechanism number two, which is a combined column mechanism. So for each one of these, you need to calculate internal force, external force equal internal to external, and get the value of MP. And finally, the one that gives you the largest MP is the critical case for your structure. So I have written all things here in detail. I don't need to explain it for you in detail. We can read it, and if you have any question, you can ask in our class next week. However, instead of this example, which is a very long example, I'm going to show you another example, which I uploaded to the e-learning system yesterday. This is a question which was given to the student during past semesters. So more or less something similar to this example we have. So either it's going to be, as I said, beam or frame, we don't know yet. But if it is frame, you may face something similar. So it is good for you to see how we can solve this problem. So I encourage you to read the one inside your note very carefully, because there are many points in the calculation of MP for that frame that is going to be useful for your test and exam. Okay, so let's see, what is this question? This question is given to us, shows one frame that has two columns with different length. The left column is 6 meter high, the right column is 3 meter. And as you can see, the MP values are not similar. The left column has single MP, and then the beam 2 MP, and the right column has 3 MP, meaning the largest section is here, and then this is the smaller cross section inside our frame. So this frame has been subjected to 2-point load. One is a sway lateral load applied exactly to the joint, 60 kilonewton. Another one is a point load applied to the middle of the beam, 80 kilonewton. And the distance from each side also is 3 meters. So it is considered to be right in the middle of it. The first part of the question, like always, is asking determine collapse mechanism. So normally this part is 3 to 4 marks in the final exam. Okay, as we learned, for frame we have 3 different mechanisms. One is beam mechanism. So beam mechanism occurs if you have point load on beam or column. So you can see one of your elements in the frame has been subjected to point load. Therefore, the beam mechanism exists for this case. And as we said in the beam mechanism, similar to the normal beams, we need to have 3 plastic hinges. So the location of this plastic hinge is going to be at the under the load, and both sides of beam or both sides of the column. So this is the basically schematic diagram of failure for the beam mechanism. We have 2 plastic hinge at the end and 1 plastic hinge under the load. Then we said for frame we have sway mechanism if we have lateral load. So this frame also has 160 kilonewton force applied to the joint. So definitely it may fail in a sway mechanism as well. So we need to investigate that one. So we said in the sway mechanism we need to have 4 hinges. And since the supports here are all fixed, therefore we need to have 4 plastic hinges, 2 at the support and 2 at the both ends of the column. This is going to be the deformed shape. And then we said we have a combined mechanism if we have point load on the beam and columns and together with lateral force. So here we have a point load on the beam and 1 lateral load. Therefore, we are going to have a combined mechanism as well. And in the combined mechanism, we said we need to have 4 hinges again. So 2 hinges is going to be at the support if they are fixed, according to the diagram that you can see. And then another hinge is going to be at the location of point load. Since we have 80 kilonewton on the beam, so one of the hinge is going to be exactly under that location of beam. If you add force here on the column, and you will see in the example that I have given inside the note, one of the hinge can be there. But right now the load has been applied to the beam, so the third plastic hinge will be under the point load. Now it comes to the fourth plastic hinge. Either is going to be in the left side or right side of the beam. So in order to distinguish which side is going to be the plastic hinge, you may examine both if you're not sure. But always, as I said, plastic hinge occurs at the location that have the largest bending moment. If you look at this frame, the right column is shorter than the left column. That means the right column can absorb much more bending moment because it is stiffer. Since it is having also a larger size and shorter column, so this part is going to be stiffer than this column. When the column is stiffer, it absorbs much more bending moment under lateral load. Therefore, the plastic hinge is going to occur at point C, the right side, not the left column. But if you're not sure, as I said, you may examine both cases, left and right, and see what's happening. There's one point here that you need to understand. The moment that you have collapse mechanism in the combined condition, if the plastic hinge is occurring in the left side, the right side always have a right angle, 90 degree. And if you assume that it is plastic hinge is at point B, then always point C is going to be a right angle. This is occurring because of the condition in which the structure is going to deform. So that means that since in the beginning of analysis, when there is no collapse, the angles are all right angles, 90 degree. When the collapse occurs, only one of this angle is going to rotate and the other one remains as it was before collapse. So this is going to help us to calculate the angles and deflections, okay? So under the basically lateral load, the frame is going to move, and the movement at point B and C is always equal, meaning when we apply the lateral load to this structure, the deflection that occurs laterally here, if this one is delta, this one is also going to be the same value. Both of them are always delta. This is also another point that you should know. Similarly, in the combined condition, if this one is moving delta, this one also is moving delta under the lateral load. So these are the points that you need to understand when it comes to the frames. Okay. So right now we got three collapse mechanisms for this frame, and now we want to calculate what is the critical MP. This is the second part of the question. So we need to do the calculation for each collapse mechanism separately. For beam, it is very easy because just now we did a lot of example for beam. So when the beam mechanism occurs, the column are at this original condition, they don't move. So we have three plastic hinges, and the force also is there, the 60 kilonewton. In this case, there is no lateral movement. It is just a vertical movement because it is a beam mechanism. So we assume that the deflection under the load is delta, and since it is exactly in the middle of the span, the rotation here and here equals to each other, theta and theta. So since the length is 3 meters, the vertical displacement is going to be 3 theta. And then one more point here is that before we go, we said when we have plastic hinges in the boundary of two different beams, we always consider the smallest one in our calculation. So you can see for this beam, the section is 2 MP, and here is MP, and here is 3 MP. So if you want to calculate the plastic moment in the left side, you'll see we need to use MP. If you want to calculate for the right side between 3 MP and 2 MP, we calculate it based on 2 MP because this is the smallest. So that's why you can see here is MP, here is 2 MP, and here is 2 MP. And then we calculate internal work. So internal work is always MP multiplied by theta, 2 MP multiplied by 2 theta, and 2 MP multiplied by theta. And external work is 80 multiplied by 3 theta. Don't forget that this 60 kilonewton doesn't do any work because there is no movement inside of our frame when it comes to beam mechanism. So from this calculation, you get MP equals to 34.3. So this was for beam mechanism. Now let's go and calculate the sway mechanism. Okay. When sway occurs, we said we are going to have 4 plastic hinge, and this is the deformed shape of our structure. This 80 kilonewton also moves together with the frame. And then we have a deflection on our structure. As I said, the amount of this deflection is delta for both sides. Is delta for both sides. So you can assume that the rotation here is theta due to the lateral load. And definitely you can easily calculate how much is this based on that. Since the height is 6 meters, 6 multiplied by theta, so this delta is going to be 6 theta. So if this delta is 6 theta, you can easily calculate how much is this angle based on theta, because the height is 3 meters. So 3 multiplied by, let's say this one, if it is beta, 3 beta should equal to 6 theta. From there, you can see beta is 2 theta. So the moment that you got this, you can also calculate the rotation of other plastic hinges. So before this, the beam was in a vertical condition, meaning the angle was 90 degrees, but right now it is rotated. So the rotation of this hinge equals to the rotation of the hinge here, because if you draw a vertical line, these two lines are parallel, so this angle equals to this angle. And similarly, the rotation of this hinge from the horizontal condition, the amount that it has rotated, equals to this one, 2 theta. So since this one is 2 theta, this one is going to be 2 theta. And right now you can calculate the internal works and external work. So again, since this 80 kilonewton doesn't have any vertical movement and it is only lateral movement, so what we have is only the external work done by this 60 kilonewton, because this is the one that has moved. There is no vertical movement here. So if you want to calculate the external work, you have only this 60 kilonewton multiplied by this delta, which equals to 6 theta. So 60 multiplied by 6 theta is the external work. For internal work, you have MP multiplied by theta, MP multiplied by theta, 2MP multiplied by 2 theta, and 3MP multiplied by 2 theta. So these are the rotation of each plastic hinge. And then if you equal them, you get MP equals to 30 kilonewton. So this is what you get from the sway mechanism. So before this, we got 34, and this one is 30. So far between these two, the beam mechanism is governing, but we have one more collapse mechanism to investigate. And that one is combined mechanism. So in the combined mechanism, we said we are going to have 4 plastic hinge because the supports are fixed. 2 of the plastic hinges are exactly at the base, and one of them is going to be under the point load, and the third one is going to be either in the right side or left side. And we said for this specific case is on the right side because this column is much stiffer than this column. It's shorter and the size of column also is larger. Therefore, it absorbs much more bending moment under the lateral force compared to this one. Okay, now we need to determine all the rotations. So we assume again here to be theta. Again, up here we have a deflection of delta, and this one also from here to here should be delta, because we said how the amount that we have the deflection in the right side equals to the left side of our frame. So since the height is 6 meters, this one becomes 6 theta from mathematics, and this one also is 6 theta. So if this one is 6 theta, again, since the height of column is 3 meters, so 3 multiplied by this equals to 6 theta, so you can get this one equal to 2 theta. This one again 2 theta, because they are the same triangle, this one also equals to theta. And since this angle remains right, 90 degrees, so if this one is theta, this angle also is going to be again theta, this one, for mathematics, because these are two triangles that have similar condition. So if this one is theta, therefore, since the load also has been applied in the middle, the other side also is going to be theta because they are going to be a similar rotation, this in the symmetry condition. And then if this one is theta and from here to here is 3 meters, 3 multiplied by theta is this delta. So you can easily calculate. And then the location of this plastic hinge rotation is the summation of these two to that. Again, you need to consider how much is the plastic moment at each hinge. We said the plastic moment depends on the MP that is given to us. So here we have MP. Therefore, the plastic hinge is going to be MP. Between these two, here we don't have any plastic hinge, but here under the load we have one plastic hinge, is going to be 2 MP. And here between these two, again, we are going to use 2 MP. At the base is going to be 3 MP. So this is what we have used for our frame in the combined mechanism. MP, 2 MP, 2 MP, and 3 MP. So now we can calculate, again, internal work. Here we have two works done. One is by 80 kilonewton and one is by 60 kilonewton. Both of them are going to be considered positive because displacement occurs in the same direction of loading. Here we put the load in this direction and the frame also move in the same direction. So this is a positive work. Here also forcing toward down and displacement also coming toward down. Therefore, it's going to be a positive work. So 80 multiplied by 3 theta and 60 multiplied by 6 theta is going to make the external work for this frame. And for internal work, it's going to be MP multiplied by theta, 2 MP multiplied by 2 theta, 2 MP multiplied by. Here, your beam has two rotations. One rotation is coming from beam, which is your plastic hinge, has two rotations. One rotation comes from the beam that deflects toward down, and another rotation comes from the column that from original condition has rotated 2 theta. Therefore, when you are calculating the internal force at this hinge, you need to sum up these two rotations. 2 theta plus theta is the rotation of this hinge. The theta comes from the beam rotation and 2 theta comes from column rotation. Therefore, the total rotation in this joint is 3 theta. Therefore, we calculate, when we want to calculate the internal force, 2 MP should be multiplied by 2 theta plus theta. And base, we have 3 MP multiplied by 2 theta at the base. So this is what you see has been given to you. And finally, if you equal internal to external, you get 35.3. So we have 35.3 from this, 30 from the second, and 34 from here. You can see that the combined mechanism is the governing mechanism, meaning if the collapse wants to occur, it's going to be the combined mechanism. And our deflected shape of our frame at the collapse condition is going to look like this frame. Looks like this frame. Okay, so right now that we know what's happening here, the question is asking, draw the bending moment at the collapse. Draw the bending moment at the collapse. So like the beams, we know that the bending moment at the collapse here equals to the value of their plastic moment. Meaning, the value of bending moment here is MP. How much is MP? 35.3. So bending moment is 35.3. Here is 2 MP, meaning 2 multiplied by 35.3. And here is again 2 MP, 2 multiplied by 35.3. And here is 3 MP, 3 multiplied by 35.3. Sometimes I can see you make a mistake. You put 35.3 for all joints. No, you need to see that with the code. You look at the coefficients of that MP because we calculate MP, and since this MP for beam and columns are not similar, the value is not going to be the same. So you can put the direction of bending moments at the same time when you calculate them. So since here the frame is moving to the right side, so our bending moment should push it back to the left side. So this is going to be the direction. And for beam, since it comes down, the bending moment should be in a direction that pushes this one toward up. Here it wants to go down the beam, so bending moment is wants to push it up, so the direction is going to be clockwise. For this column also, since it wants to rotate to the right side, the bending moment should be counterclockwise to bring it back to its original condition. So this is going to be the condition of our frame at the time of collapse, together with the direction. So 2 MP, MP, these are the location of plastic hinge with the value. Now, if you want to draw the bending moment diagram, we know the value of a bending moment at this location, but we don't know how much is bending moment at point B. At point A we know, point D we know, point C we know, and under the load we know, but point B is not clear. So first we need to calculate how much is bending moment at point B, and then we can draw the bending moment diagram because the other values are clear. If you want to calculate the bending moment at point B, you need to calculate first the support reactions. So this is what we have done. We have cut the column at point C, and then we have written down sigma of y equals to 0. So if you cut it from here, you have two bending moments up and down. And then sigma at point C should be 0. You can calculate Px. sigma if y equals to 0, you can calculate dy. So these are the values that we have obtained for dx and dy. So we got the support condition here. Then we can calculate the support condition at point A as well. This is again the continuation of the same calculation to get dy. After you calculate dx and dy, you can easily calculate ax and ay as well. And then these are the values that we have obtained for the support reaction. And the moment that you got the support reactions, you can easily calculate the bending moment at B. You just cut it from there and then write down sigma m at point B equals to 0, and you can calculate the value. So right now we know the value of bending moment here, here, and here, and here, and here. We just need to put them there and connect them to each other to get the bending moment diagram, considering the positive sign for bending moment. And this is going to be the diagram for bending moment. So you can see, in order to solve the problem, first we determine the possible collapse mechanism, and then after that we calculated for each collapse mechanism how much is the MP. After that we compared them and we selected the largest MP as the critical one. For that largest MP, we look into the collapse condition, and then we calculated the bending moments at the plastic hinge, and got the bending moment in the location that we didn't know the value, and finally we draw the bending moment diagram. So this is a very good example for you for the condition that the combined mechanism is combination of lateral force and beam. If the force was applied to the column, your combined mechanism is going to be a combination of sway and column mechanism. So this is something that you can find it in the example that I have solved in the note. So it's not going to be outside of these two cases. Either is beam and sway or column and sway. And if you learn both of them, so you should have any problem for the exam. Okay, so that's all for our lecture. And with this, basically, we can close the lecture. So for our next week, we are going to have your test 2. I want to know who is the class representative. Can you please let me know your name? I think it is Mr. Bad, right? Badder? I don't know the correct spell.
No, doctor. I think he's Leon.
Leon. Okay, Leon.
Yeah.
So, okay, so you are the class representative, and yes. Do you know exactly when is going to be the date that the students suggest?
Okay. So most of us have the exam foreign language on the 23rd to 23rd to 25th, or 23rd to 27th. So we suggest that 28 and 29 would be the possible dates for the test 2. Yes.
Okay. So 28 and 29. So I need to discuss this with our students in another section tomorrow, and then I will confirm with you that when is going to be the final date. If they could come in one of these 2 days, 28 and 29, then I will match you together with them and give you same questions. If they couldn't come, then I will inform you that the exam will be exactly at the class time, meaning next week, same time that we have the class, you will have your test. It depends if the other sections tomorrow that I have another section with them, they can come at 28 and 29 on either of these two. So we just merge you all together. If not, then I will change it and I will inform you. For your information, the test 2 is going to cover only 2 parts. It's going to be 2 questions coming from influence line and also 1 question from truss. So there is not going to be any question for classic analysis in test 2. But in your final exam, as I said, you have 1 question from compulsory question from normally it is compulsory from the plastic analysis as well. So try to learn the plastic analysis very well and solve all the example by yourself and see whether you can do it or not. And then for your actually case study. As I said, please record the video, maximum 10 minutes, and upload it together with your presentation slide and also your report, all in PDF format. Presentation slide and your report in PDF format together with the video, and make sure that the video size is not too much large. I selected it to 100 megabyte. So don't make it larger than that, and try to ask other group members to involve inside your presentation, so that the class is going to be everyone there. So that's all. If you have any question, I can see one of your friends is asking a question. I have a question for question C. The beta is 4/11, theta. Okay, can you ask your question, C1 Yun? What is exactly the question that you want to ask?
That part is before the rest after when we take the break. There was a quite long period.
Okay, so no problem. It is regarding the beam or the frame?
For the solution for question 3.
Oh, okay. Okay, so you got the answer, right?
Yeah, I have the answer. Just I saw the beta is 4/11. Then because I don't know how to get 4/11, I get 4/7.
So let me go back. So you're talking about this question, right? Is it this one?
The white color one, not
Oh.
the blue paper. Wait, I go and find.
So if it is the white color, it is the PDF file. Okay, you're talking about this one?
Yes.
Okay,
The second question.
Okay, second question. Okay, here.
For question C, the beta is 4/11 or 4/7.
Beta here. Okay. The link is given to you. So it is the combination of
5+2, right?
Pardon me? So you calculate first delta. Delta is based on the length of this span is 4 theta, because from here to is 4 meter.
Yeah, 4 theta equals to.
Okay, so this is for 4 theta, and the beta is going to be
7.
From here to the load of 10 is 5 meter. So from here to is 5 meter. So delta 2 is going to be I got your point right now. Okay, I think this is the mistake in the question here. This is 3 meter, not 5 meter. This one. If this one is 3, yes, this is 3. Yeah. If this one is 3, then that one is going to be okay, because it's going to be 3 plus 2, 5. So 5 delta 1 equals to.
I think.
No. It's correct. It's correct.
Yeah,
because this one is this one is delta 2. You see, it is 5 beta.
No, for the right a bit above the yeah, this one I think it's 4/7, is it?
Okay, we can calculate this one. So these two, delta 1 we got it, delta 2 we got it, and then delta 1 over delta 2 is going to be 11/5. So if it is 11, means from this point to this point should be 11/5. Okay, so I think I found the mistake. The mistake is, okay, this is going to be 6 meter, not 2 meter. This is the mean. If you assume this one is 6, then it's going to be okay.
Okay, thank you, doctor.
Yeah, this is 6 meter. Because if it is 11, that means from this support until the point of 15 kilonewton, from here to here should be 11. Okay, this is the triangle. 11/5 should equal to delta 1 over delta 2. So in order to be 11, from here to here should be 11 meter, but this one is written 2 meters. So this one you need to make it 6. Okay. If it is 6 meters, then you will be fine. It's going to be 11/5. And then from there, you can calculate delta 1 based on delta 2 and put beta there, and it's going to be okay. Thank you for the question. Okay, so that's all. So we can stop our lecture here. I just need to see who is on the class, and then you can leave.
Doctor,
Yes.
the test will be on which chapters?
I just explained. I said the test comes from influence line and also the trust analysis.